To locate a discontinued Greenlee electrical training tape, there are several avenues to explore. Firstly, check online marketplaces like eBay and Craigslist for used copies. Filter search results by location to increase your chances of finding a local seller. Secondly, reach out to other electrical apprenticeship schools or community colleges in the area. They might have a copy of the tape in their libraries or archives. Thirdly, contact local electrical contractors associations. Their members might have access to training materials or know someone who does. Despite the tape being out of production, contact Greenlee customer support to inquire about any remaining stock. There are independent companies that provide electrical training materials. They might have access to older tapes or digital versions. Join electrical apprenticeship or Greenlee-related groups on platforms like LinkedIn or Facebook. Post a request for the tape and see if anyone has a copy. If the tape cannot be found, there are alternative options. Greenlee might offer digital training modules on their website or through their distributors. These modules might cover similar topics to the tape. There are numerous online resources that offer training videos on electrical bending, pulling, fishing, and other related topics. Consider using these as a substitute for the tape. Contact former students who may have taken the course when the tape was still available. They may have a copy or be able to point in the right direction. When searching online, use specific keywords such as Greenlee training tape, electrical apprenticeship training video, and Greenlee bending techniques. Check the condition of any used tapes before purchasing them to ensure they are in good working order. When contacting trade schools and community colleges, inquire about their policy on sharing or copying training materials. Some institutions may be willing to provide a copy of the tape for educational purposes. When reaching out to electrical contractors associations, ask if they have any training programs or resources that cover similar topics to the Greenlee tape. When contacting Greenlee customer support, provide the model number or any other identifying information about the tape. This will help them determine if they have any remaining stock or if they can offer alternative training materials. When exploring independent training providers, research their reputation and credentials to ensure they offer quality training materials. When joining online groups, be respectful and professional in your requests for the tape. Explain why you need the tape and how it will benefit your students. When considering digital training modules, check the system requirements to ensure they are compatible with your school's equipment. When using online training videos, preview them carefully to ensure they are accurate and up to date. When contacting former students, be mindful of their time and privacy. Explain why you are looking for the tape and how it will help current students. If you find a copy of the tape, make sure it is compatible with your VCR player. If you are using a digital projector, you may need to convert the tape to a digital format. Consider creating a digital archive of the tape to ensure it is preserved for future generations. Provide your students with clear and concise instructions on how to use the training materials. Encourage your students to ask questions and seek clarification on any concepts they do not understand. Regularly assess your students' understanding of the material to ensure they are learning effectively. Update your training materials as needed to reflect changes in industry standards and best practices. Seek feedback from your students on how to improve the training program. Celebrate your students' successes and recognize their achievements. Create a supportive and collaborative learning environment. Foster a culture of continuous improvement and lifelong learning. The information contained in the training tape is assumed to be based on the National Electrical Code, or NEC. The NEC is a comprehensive set of standards for electrical wiring and safety. Some of the key concepts covered in the NEC include wiring methods, overcurrent protection, grounding, and bonding. Wiring methods refer to the types of wiring that are permitted for different applications. Overcurrent protection is designed to protect electrical circuits from excessive current, which can cause overheating and fires. Grounding is a safety measure that helps to protect people from electric shock. Bonding is the process of connecting different metal parts of an electrical system together to create a low impedance path for fault current. When working with electrical systems, it is essential to follow the NEC and all other applicable codes and standards. Doing so will help to ensure the safety of people and property. Here are some examples of typical electrical calculations. Ohm's law states that voltage equals current times resistance. This can be written as volts equals amps times ohms. For example, if you have a 120 volt circuit with a 10 ohms resistor, the current flowing through the circuit will be 12 amps. The power dissipated by a resistor is equal to the voltage squared divided by the resistance. This can be written as power equals volts squared divided by ohms. For example, if you have a 120 volt circuit with a 10 ohms resistor, the power dissipated by the resistor will be 1440 watts. The total resistance of resistors in series is equal to the sum of the individual resistances. For example, if you have 3 resistors in series with resistances of 10 ohms, 20 ohms, and 30 ohms, the total resistance will be 60 ohms. The total resistance of resistors in parallel is equal to the reciprocal of the sum of the reciprocals of the individual resistances. For example, if you have 3 resistors in parallel with resistances of 10 ohms, 20 ohms, and 30 ohms, the total resistance will be approximately 5.45 ohms. The current in a parallel circuit divides among the branches, with more current flowing through the path of least resistance. The voltage across each branch of a parallel circuit is the same. The power in a circuit is equal to the voltage times the current. This can be written as power equals volts times amps. For example, if you have a 120 volt circuit with a current of 10 amps, the power will be 1200 watts. When selecting wire size, it is important to consider the ampacity of the wire. Ampacity is the maximum amount of current that a wire can safely carry. The NEC provides tables that list the ampacity of different wire sizes. For example, according to NEC Table 310.15b16, a 14 American wire gauge (OG) copper wire with type THHN insulation has an ampacity of 15 amps at 30 degrees Celsius. When selecting overcurrent protection devices, such as circuit breakers or fuses, it is important to choose a device with an appropriate ampacity rating. The ampacity rating of the overcurrent protection device should be no greater than the ampacity of the wire it is protecting. The NEC provides guidelines for selecting overcurrent protection devices. Grounding is a critical safety measure in electrical systems. The purpose of grounding is to provide a low impedance path for fault current to return to the source. This helps to protect people from electric shock. Grounding systems typically consist of a grounding electrode, such as a ground rod or a metal water pipe, and a grounding conductor. The grounding conductor connects the grounding electrode to the electrical equipment. Bonding is the process of connecting different metal parts of an electrical system together to create a low impedance path for fault current. Bonding helps to ensure that all metal parts of the electrical system are at the same potential, which reduces the risk of electric shock. Bonding is typically accomplished by using bonding jumpers, which are short lengths of wire that connect different metal parts together. Electrical enclosures are designed to protect electrical equipment from the environment and to protect people from electric shock. Enclosures are typically made of metal or plastic and are available in a variety of sizes and shapes. Enclosures are rated according to their ability to protect against different environmental conditions, such as water, dust, and corrosion. Conduit is a type of tubing that is used to protect electrical wiring. Conduit is typically made of metal or plastic and is available in a variety of sizes and types. Conduit can be used to protect wiring from physical damage, moisture, and corrosion. There are different types of conduit, such as rigid metal conduit, or RMC, intermediate metal conduit, or IMC, electrical metallic tubing, or IMT, and flexible metal conduit. Each type of conduit has different properties and is suitable for different applications. Electrical boxes are used to house electrical connections. Electrical boxes are typically made of metal or plastic and are available in a variety of sizes and shapes. Electrical boxes are used to protect electrical connections from the environment and to provide a safe place to make splices and termination. There are different types of electrical boxes, such as junction boxes, outlet boxes, and switch boxes. Each type of electrical box is designed for a specific purpose. Wiring devices are used to control and distribute electrical power. Wiring devices include switches, receptacles, and dimmers. Switches are used to turn electrical circuits on and off. Receptacles are used to provide a convenient source of electrical power. Dimmers are used to adjust the brightness of lights. There are different types of switches, receptacles, and dimmers available, each with different features and capabilities. Lighting is an essential part of any electrical system. Lighting provides illumination for people to see and work safely. There are different types of lighting available, such as incandescent lighting, fluorescent lighting, and light-emitting diode, or LED, lighting. Each type of lighting has different properties and is suitable for different applications. Incandescent lighting is the oldest type of electric lighting. Incandescent lamps produce light by heating a filament until it glows. Fluorescent lighting is more energy efficient than incandescent lighting. Fluorescent lamps produce light by passing an electric current through a gas. LED lighting is the most energy efficient type of lighting. LED lamps produce light by using semiconductors. Motor control is the process of controlling the operation of electric motors. Motor control systems are used to start, stop, and protect electric motors. Motor control systems typically consist of a motor starter, a motor controller, and a motor overload relay. The motor starter is used to start and stop the motor. The motor controller is used to control the speed and torque of the motor. The motor overload relay is used to protect the motor from overload conditions. Transformers are used to step up or step down voltage. Transformers consist of two or more coils of wire wound around a common core. The ratio of the number of turns in the primary coil to the number of turns in the secondary coil determines the voltage transformation ratio. For example, a transformer with 101 turns in the primary coil and 10 turns in the secondary coil will step down the voltage by a factor of 10. Transformers are used in a variety of applications such as power distribution, electronic equipment, and lighting. Generators are used to convert mechanical energy into electrical energy. Generators consist of a rotating coil of wire in a magnetic field. When the coil rotates, it induces a voltage in the wire. Generators are used in a variety of applications such as power plants, emergency power systems, and portable power sources. Safety is paramount when working with electrical systems. Always follow safety precautions to protect yourself from electric shock. Wear appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and insulated tools, to energize electrical circuits before working on them. Use a voltage tester to verify that the circuit is de-energized. Never work on live electrical circuits. If you are not qualified to work on electrical systems, hire a qualified electrician. Electrical training is essential for anyone who works with electrical systems. Training provides the knowledge and skills necessary to work safely and effectively. There are many different types of electrical training available, such as apprenticeship programs, vocational schools, and online courses. Choose a training program that meets your needs and goals. Continuous learning is essential for staying up to date with the latest electrical codes, standards, and technologies. Attend continuing education courses, read industry publications, and participate in professional organizations. The electrical industry is constantly evolving, so it is important to stay informed and adapt to new changes. Greenlee is a well-known manufacturer of electrical tools and equipment. Their products are widely used in the electrical industry. If you are using Greenlee tools and equipment, make sure you are properly trained on how to use them safely and effectively. Refer to the manufacturer's instructions for proper operation and maintenance. The NEC is updated every 3 years. Make sure you are using the latest edition of the NEC. The NEC is a complex document, so it is important to study it carefully and understand its requirements. Consult with a qualified electrician or electrical inspector if you have any questions about the NEC. Understanding electrical concepts and safety practices is crucial for anyone working with electrical systems. By following safety precautions, seeking appropriate training, and staying up to date with the latest codes and standards, you can help to ensure a safe and productive work environment. Remember to always prioritize safety when working with electricity.